Okay, in this activity, we're setting up default static routes and network static routes from R1, R2, and R3 to each other's unknown networks. So, using IPv6. So if we look at R1 here, the directly connected networks that it's aware of, the first one being 2001 DB811. Remember, that is the network ID, the first 4 hectets. Hectet being of 16 bits, and 16 times 4 is 64. So, and recall that the zeros, the leading zeros, are left out. So we really have 4 hexadecimal numbers here, each hexadecimal number being represented by a quadtet, which is 4 bits. So 4 times 4, there's 16 bits per placeholder in a IPv6 or a hextet in an IPv6 address. So there's the first 16 bits. Here they've left out the leading 0, so that is actually, again, 16 more bits when we include the leading 0. Here they've left out the 3 leading zeros, so that's actually 0, 0, 0, 1, and there's the third hextet. And again, here we've left out the 3 leading zeros, 0, 0, 0, 1, and that's the fourth hectet. 4 times 16, 64. So our network here is 2001 DB811, and it is, and this is on the. If we come up to see if it'll let us turn this on, always show port labels. Let's close that back out. We'll see that is on the G00 interface of R1. On the serial 000 interface of R1, we have the network 2008 DB8 1 alpha 001. Okay. On the other end, on R2, we have R1 connected to R2 via serial 000 going to serial 000 on R2. That is the same network, again, 2001 DB8 1 alpha 001. So the networks that R1 does not know about is 2001 DB8 1 2, 2001 DB8 1 alpha 002, and 2001 DB8 1 3. So we need to tell R1 about these 3 specific networks in order for R1 to be able to route packets on behalf of any of its own networks. So we'll open up the router R1. Of course, we have to go to global configuration mode, which I've already done. And then we issue the IPv6 static route command. So that's IPv6 route, the network we want to route to. So we're going to go ahead and plug in the first network up here sitting off of R2, the 2001 colon DB8. And remember, I could specify this as 0 DB8 if I like, but the rules of IPv6 say to omit leading zeros. So that's DB8 colon ACAD, colon 1 colon 0002, right? But we delete the leading zeros. So it's 2001 DB8 1 2 colon, and we have to specify the prefix for the network, space, and we can give it an exit interface in this case. Unless we're using Cisco Express Forwarding routing, then an actual recursive lookup is preferred. Now the directions tell us, what do the directions on this particular activity tell us they want to do? First and foremost, we have to enable IPv6 routing on all routers. So we do need to go back and do that first. And that is the IPv6 unicast-routing command. That enables IPv6 to be routed on this router. We must, IPv4 is routed by default. If we want to route IPv6, then we must enter that command on every router which we intend to route IPv6. So we'll go ahead and enable that on all the routers. IPv6 unicast routing, least we forget. We need to go ahead and make sure that's done, or all of our efforts at trying to implement static routing will be for naught. So we go back to each router into global interface mode and IPv6 unicast routing, and that enables now routing for IP version 6 on this network. Okay, so now we'll go back to our directions. Let's make sure we are doing the correct thing. Configure a recursive static route on R1. Configure an IP version 6 recursive static route to every network not directly connected to R1. Okay, so a recursive static route tells us that it wants it to be to a next hop router. Okay, so we go back to our R1 and we're going to do the IPv6 route command. That's how we start out a static route. The network that we want to reach, so again we're going to plug in this network up here off of G00 on R2. Okay, so we're going to plug in 2001 colon DB8 colon 1 colon 2, and then we have to give it the network prefix so we can tell the router exactly which portion of that address is indeed the network we're trying to reach. And then we either give it an exit interface, but since we're doing a recursive route, that means we need to do a next hop. So in other words, we have to determine what is the next hop address, the IP version 6 of R2 here. That's the next hop for R1. Okay, so we need to determine what is serial 000's interface on R2. Now we could go out to R2's command line, and without a network topology we could get back to a privileged exec mode, and we could do a show IPv6 interface brief command, and there it shows us that serial 000, okay, on R2, and it shows us what its address is right there. So that is our next hop address that we'll use in our static route on R1. So we'll put this to the side where we can see it, and we'll come over and we will say the next hop is 2001 DB8 colon 1 colon alpha 001 colon 2. Now that is an actual IP version 6 fully qualified IP address. Okay, so all of the, remember, recall with IP version 6 we can replace successive zeros with the colon sign. So those are all zeros in there to fill out the 128 bits of the fully qualified IP version 6 address. And we hit enter, and now if we do a, let's exit out of here, get back to our privileged exec and do a show IPv6 route statement, we should see now we have one static route that has been added to reach the 2001 DB8 1.2 network via the next hop router of 2001 DB8 1A 0012. Okay, so there's our first network. Alright, so let's go and add the remaining two networks, and they're both going to use, of course, the same next hop address right here. That is the next hop to R2. Alright, so they have to traverse through R2 to reach all of those networks, regardless, even the R3, right? Because the R3 network is, in order to be reached by R1, it will have to traverse R2 to reach the network off of the gigabit 1/1 interface off of R3. Alright, but now keep in mind, in order to reach the gigabit address off of R3, the 2001 DB8 1.3 network, R1 doesn't know about that network, but neither does R2. So in order for R1 to fully reach all the way around to this network, we're going to have to put an entry in also on R2 that indicates where to go to reach that network. But let's go ahead and put the entry in first for R1. So, and we'll go ahead and put the entry in for this next network right here first. So that's very simply, we go to global config mode, IPv6 route, and we're trying to reach the network 2001, this network right here, okay? So we're trying to reach the network 2001 DB8 1 colon alpha 002 colon again the prefix that indicates the network that we're actually trying to reach here, and then the next hop address. So again, we're going to go to this address. That is the IP address of the serial 00 interface, serial 000 interface of R2, and that is our next hop from R1. So we'll plug that in there. Remember, this is a recursive route entry that we're adding because it uses a next hop instead of a interface ID. Okay? So that one should be now showing. So if we do a do instead of exiting out, as you recall, we can use the command do. Alright, so instead of exiting out of global config, going back to privileged exec mode, we can just issue that command from here using the do show IPv6 route, and we should have a second route statement now that's in our route table entry. And there it is, DB8 alpha 002 and DB812. So the DB812 is this network up here. The DB8 alpha 002 is this network here. That's the interconnection between R2 and R3. And now let's finally, on R1, add this third network. No difference in how we do it. Again, IP version 6 or IPv6 route, and the network we're trying to reach, 2001 DB8 1 3 /64, our network prefix, and we're going to the next hop interface of 2001 DB8 1 alpha 001 2. And again, we can do a show IPv6 route to make sure that route is indeed in there. And which one was it we were adding? We were adding this 13, and here we have the static route entry for the network 2001 DB813 via 2001 DB8 1 alpha 0012, which is our next hop ID. Okay.